Today we're going to discuss a method that will help you measure up with the rest of your classmates when it comes to figuring out these arc, circumference, or central angle problems. It's actually as easy as pie, so let's jump into it and get cooking. First, there are three different ways that you can measure a circle. First is going to be the area. Next, the circumference. Let's call this area method 1. Method 2 is going to be circumference. Finally, the central angle. That's 360 degrees or 2 pi radians. I'm going to call this 3 and 4 because it could be expressed two different ways, but they're both ultimately measuring the angle. Likewise, you can measure the wedge in three ways as well. You can measure it as far as the area, as far as the circumference of the wedge, which is known as the arc, or the angle known as the central angle right here. And all of these can give you information about the magic proportion, which is to say, what proportion is this wedge, the attribute of this edge, whatever it is we're measuring, compared to the entire circle. So what is the proportion, for example, of the area of the wedge compared to the area of the circle, the circumference of the edge known as the arc to the circumference of the circle, and then the central angle compared to the entire angle of the circle. Now this proportion, the magic proportion, I call piece over cake, where the top part is going to be the piece as far as whatever attribute we're measuring, and then the cake is going to be the entire cake, the entire circle, as far as the attribute that we are measuring. So let's get into it with some real numbers. Say this area of the wedge is 8 pi, and then the entire cake is 64 pi. So meaning the entire cake, including the wedge, is 64 pi. So then I know that my magic proportion, my piece over cake, is going to equal 1 over 8. And I could use this 1 over 8 for the rest of the problem. Let's skip to 3 and 4 for a second. And let's figure out, well, I'm going to set up the proportion first. Piece over cake for, let's say, degrees. Well, I know that cake for degrees, for the entire cake, there are 360 degrees. And for piece, well, I don't know because I'm not given information. I'm going to call that x. Well, I know that these three are the same cake. And from number 1, I gleaned that 1 over 8 is going to be the magic proportion. So 1 over 8 equals x over 360. X is going to equal 45. So there are 45 degrees in this angle. And I did this intentionally with degrees first. Now let's move to circumference, because I can actually figure out the entire circumference of the circle with the information that was given, and by extension, the arc. Okay, so first thing we do is piece over cake. Well, piece is x, and then cake, I'm also not given the circumference, but I actually am, because circumference can be expressed as 2 pi r. That's the circumference of a circle. And I know what r is based on this problem over here. How so? Because cake over here can also be described as pi r squared. Pi r squared equals 64 pi. Cross out the pi, r squared equals 64. So that means r equals 8. If I substitute that in, I'm going to substitute for piece over cake. Well, I know piece over cake is 1/8. That stays the same throughout for 1, 2, and 3. 1/8 equals x over 2 pi r. R is equal to 8. So that's going to be 16 pi, which means x equals 2 pi. So once you figure out this magic proportion, you can then figure out the piece over cake for the rest of them. Just do piece. Okay, how do I figure out piece? Usually you cannot figure it out without the 1 over 8 for piece unless they tell it to you, unless it's given explicitly. Then that's going to be over cake, and cake can be explicitly, but can also be figured out for area and for circumference. You're going to follow the formula, and then for 3 and 4, for angle measure, cake is going to be 360 degrees. or 2 pi radians. That means the same thing, that's just unit conversion. Okay, let's go ahead and try to apply this. In a circle with center O, we always draw this out. O, central angle AOB has a measure of 5 pi over 4 radians. Okay. This over here. 5 pi over 4. I don't even know what that is. The area of the sector formed by central angle AOB is what fraction of the area of the circle? Okay. Area of the sector formed by central angle. So this area is what fraction of the area of the circle? So that's going to be piece over cake. This area is x, and this area for that matter is pi r squared. But what's the problem? There's no information given about r, nothing about x. So the only way to, but let's backtrack a second. I'm not asked to figure out what x and pi r squared are. I'm asked to figure out what piece over cake is. Well, that's my magic proportion, and you could figure that out in one of 3 ways. Either by figuring out the relationship between the area of the wedge to the area of the circle, the circumference, the arc compared to the circumference, or the central angle. Well, in this case, I'm actually given the central angle. So let's try again and do a piece of cake equals, well, I'm given piece, that is 5. So I'm doing this piece of cake now for angle measure in radians, and cake for radians is going to be 2 pi. And let's actually do rad. Let's do rad. This is now algebra. Let me do this division. I'm going to multiply by the reciprocal. I'm going to consider this to be the numerator, this to be the denominator. I'm going to multiply by the reciprocal, 5 pi over 4 rad times 1 over 2 pi rad. Pi and rad is going to cancel out, and I'm left with 5 over 8. Now notice here that the pi's canceled out, that's good, and the radians canceled out. And that's really good because this is a proportion. This magic proportion is unitless because we're using it for all 3. For the first with area, we're going to have squared. The unit is going to be squared. Circumference, the unit is going to be just to the power of 1. And finally, in that third, it's going to be given as degrees or radians. So we do not want this magic proportion to have any units. The units cancel out, and that's a good way to check that I did my division correctly. Next, points A and B lie in a circle with radius 1. A and B. And arc AB has length pi over 3. So piece over cake. I already know that piece is given as pi over 3. Remember, the only way to figure out piece is either if it's given explicitly or if you figure out from the magic proportion. What fraction of the circumference of the circle is the length arc AB? So this is actually just the magic proportion. Length of arc AB, that's piece. Circumference of the circle is cake. I'm just asked for a piece of cake, and I'm given the components almost explicitly. So piece equals pi over 3. Cake is pi r squared. Well, they give me r, that equals 1, so that's just pi. Excuse me, what am I doing here? Equals, cake equals 2 pi r. Constant vigilance. Okay, pi over 3 over 2 pi r. R is going to equal 1, so I have pi over 3 over 2 pi. I do the same thing as before with that division. Pi over 3 multiplied by the reciprocal, 1 over 2 pi. And this is in radians. This is in radians. Radians cancel, pi cancels, and I'm left with 1 over 6. And again, unitless and without pi, and that's going to be my answer. It was pretty straightforward. Okay, let's move to the final 2 problems here. This is likewise an SAT problem. The circle above with center O has a circumference of 36. What is the length of minor arc AC? Okay, so now we're going to start to get into figuring out that proportion from other parts information that is not necessarily given explicitly in the problem. So we already drew it. Okay. Circumference of, I'm just going to exit that. I'm going to draw it right in here. Circumference of 36. What is the length of minor arc AC? So let me do piece over cake in terms of circumference. Well, cake is given explicitly as 36, and we're trying to find this AC, so that's going to equal x. So I need to figure out what the magic proportion is, what piece of cake is in this problem, and I have all two ways to do that. Either you figure it out from area, if the area of the wedge compared to the area of the circle is given, or you figure it out from degrees or radians, if the angle of the wedge is given compared to the angle of the rest of the circle. In this case, luckily, the angle of this wedge is given as 90. So I could do a piece of cake for that. In terms of degrees, I have 90 over cake is going to equal 360 equal 1 over 4. So I know that my magic proportion equals 1 over 4. X over 36 equal 1 over 4. X is going to equal 9, which is A. I want to show you one thing before we proceed to the next problem. Let's say I was asked for the circumference of the area not in AC, so going this way. What would I do? So you could do two things. You can do 36 minus 9, that would give you the answer. What I like to do, though, is figure out the magic proportion for the other area and then just consider it to be my wedge. So in this case, you would do 1 minus 1 over 4. You're going to do 1 minus the area of the wedge that you're given, equal 3 over 4. So 3 over 4 is my new magic proportion. And then I can go ahead and do x over 36 equals 3 over 4 and solve from there. Okay, good. This last one is a homebrew, and this is pretty much how as difficult as it gets. You're not going to see all of these things in one problem, all these little confusing parts, but you will see them on the SAT. So let's jump right into it. A circle with radius 4 has a wedge with area 2 pi meters squared. What's the circumference of the arc not contained in the wedge? Okay. So first we have to figure out our magic proportion, and then we could do 1 minus that to get our new magic proportion that we're going to use for the second part of the problem. So let's first do piece over cake. The information that I'm given at first is going to be the area of the wedge. So this is going to be piece of cake for area. First is going to be 2 pi. Now cake. I'm not given it explicitly in this problem, but I am given it implicitly as far as the radius. So that's going to be equal 2 pi over 16 pi. Radius is 4, which further simplifies to 1 over 8. So my magic proportion given as far as the area that is in the wedge is 1 over 8. And if I want to figure out the circumference of the arc, then that's in the wedge, I would use 1 over 8, but that's not what I want to figure out. The arc not contained in the wedge. So I'm going to do 1 minus 1 over 8. That equals 7 over 8. So 7 over 8 is my magic proportion. Now we can move to the second part. What's the circumference of the arc not contained in the wedge? Okay, piece over cake. The arc is x equal x. And then the cake is going to equal, you know what, I'm just going to do it like this. Arc, and the cake is going to equal 2 pi r. Well, I'm given r, radius 4, equal x, radius 4, 8 pi. Okay, so now this is my piece of cake. Well, piece of cake before, I solved as 7 over 8 equal x over 8 pi. And then I could recognize that 8 goes to 8 pi as 7 goes to 7 pi. So my answer would be 7 pi. Now, if I was asked to find the area, the circumference of the arc, the length of the arc in the wedge, then I would just use that 1 over 8, and that would be just pi. Or I could recognize that 8 pi minus 7 pi equals just pi. Again, just figure out the piece of cake first, set up the problem, realize what you're doing the piece of cake for. If it's area, set it up from there. And then really the two tricks that they can throw at you, number one is you're figuring out the part that is not in the wedge. So you just do 1 minus, or you could figure out that they'll give the radius, or they'll give even the area, the entire area of the circle, and then you have to deduce the radius from there and then apply that to the circumference. But other than that, it's pretty straightforward. I hope this is helpful for you. Good luck studying, and then good luck on test day.